Hey everybody, this is Mr. Longo here, and this video is going to cover the quadratic formula and the discriminant. There's a good chance you are already pretty familiar with the quadratic formula, but we're going to take it a step above in this class. So before you use the quadratic formula, make sure you are aware that you must be in standard form. A is a leading coefficient before your x squared, then you have b, which is the coefficient of x, and then c, which is your constant. And no surprise, your quadratic formula is x is equal to the opposite of b plus or minus the square root of the entire quantity b squared minus 4ac, and that is all over 2a. Now, just the inside of your quadratic formula, that is known as your discriminant. Now, the discriminant is important because it's going to tell you what types of solutions you're going to have. So if you have a positive discriminant, you're going to have two real solutions. Now, to take that even a step farther, if it's a perfect square, then you're going to have two rational answers. If it's just any other positive number that's not a perfect square, your answer is going to be irrational, like the square root of 8 or something. If you have d is equal to 0, or a discriminant of 0, then you're only going to have one real solution. That's because you can only take the square root of 0. There's no plus or minus 0, because 0 is obviously just 0. It's neither positive or negative. Finally, if you have a negative number for your discriminant, you're going to have two imaginary numbers because the square root of a negative is imaginary. But remember, whenever we're solving for x and take a square root, we have our plus or minus option. Now, graphically, two solutions would just mean it crosses the x-axis twice. One solution would mean it just nicks the x-axis once. And imaginary solutions would mean it doesn't touch the x-axis at all. So that's graphically what these would look like. Okay? So let's go do a little bit of practice. First example, we're just going to find the discriminant and state the solution types. So our discriminant is b squared minus 4ac. For this problem, it would be 7 squared minus 4 times 1 times 10. So 49 minus 40 is going to give us 9. So 9 is a positive number, and it's a perfect square. So we would have two real, rational solutions. Okay? So that's a little example for you on that. So when we're working with the quadratic formula, in a way, you're always going to be finding the discriminant. So we're just going to take these a step above, and then as we get to the discriminant part, we'll talk about it. So our second example, if we were to do the quadratic formula, the entire thing, x would equal the opposite of b. So this is a negative 12, so it's going to be a positive 12, plus or minus the square root, and here's our discriminant part. It would be negative 12 squared minus 4 times 2 times 18, and that's all over 2 times 2. To simplify that up a little bit, we're going to have 12 plus or minus the square root of 144 minus 144 all over 4. Now we know that 144 minus 144 is going to give us 0. So what that step would look like is just 12 plus or minus the square root of 0 over 4. Now since the square root of 0 is just 0 and there's no positive or negative, our final answer is just going to be x is equal to 12 over 4, which is 3. So x is equal to 3. Now that takes us back to our discriminant being 0. We only have one solution because 0 is neither positive or negative, so we just have x is equal to 3, one solution. Okay? Let's jump to example number 3. First thing you would have to do is obviously add your 9 over to the other side to get it in standard form. So that would be x squared minus 4x plus 9 equals 0. So to use the quadratic formula, x is equal to the opposite of your negative 4 is going to be positive 4 plus or minus the square root of b squared, which is our negative 4 squared, minus 4 times 1 times 9, all over 2 times 1, which is 2. So inside of our radical, for our discriminant part this time, x is going to equal to 4 plus or minus the square root, and 16 minus 36 is going to give us a negative 20, all over 2. Now, as you can see, we have a negative number, so our discriminant is negative, telling us we're going to have two imaginary solutions when we finish solving. So the square root of a negative 20 is going to simplify, so we're going to have x is equal to 4 plus or minus 2I root 5 all over 2. And this is a nice little trick that I would use, is whenever you have a numerator that's got multiple parts and only one denominator, you can split. So I would rewrite this, just so it's easier to work with, 4 over 2 plus or minus 2I root 5 over 2. And now you can see easily that this can cancel to 2. So we have 2 plus or minus, and these two can cancel I root 5. Okay, so again, x is equal to 2 plus or minus I root 5, and that tells you there's two imaginary numbers. A positive and a negative I root 5 will give you two different imaginary solutions. All right, so that is the quadratic formula. There's one last question for these notes, and it is to determine what value of c would give you two real, one real, or two imaginary solutions. So obviously we have a positive, we have negative, and we have 0. So the one in the middle is 0. So what we're going to do is just take our discriminant, b squared minus 4ac, and set it equal to 0, just to find out our main number for c that we need to work with, and then we can think about what's going to make it negative, what's going to make it positive. So we're going to start by saying b squared minus 4ac, so that's going to give us a negative 3 squared minus 4 times 2 times c, and that's equal to 0. So 9 minus 8c equals 0. So a negative 8c is equal to a negative 9. So c is equal to 9/8. Okay, so we now know that if c is equal to 9/8, we're going to get 0. And now remember, we need to figure out the constraints for two real, one real, and two imaginary. So if c is equal to 9/8, that gives us 0. That's where we have our one real solution. So here's the tricky part. We just need to figure out if c is greater than 9/8, what does it do? And if c is less than 9/8, what does it do? So let's pretend that c is greater than 9/8. If c is greater than 9/8, then this minus 4 times 2 times c is going to get bigger, which means we would have a negative number, because this would be 9 minus something greater than 9. So a negative number would give us two imaginaries. So if c is greater than 9/8, we will get a negative number giving us two imaginary solutions. So that means the other option is going to go with two reals. So if c is less than 9/8, it'll be a positive discriminant, leaving us with two real solutions. Okay, that's it for this video on the quadratic formula and discriminant. This is Longo, and I'm out. See you, bye.